Okay, so in this video, we're going to be talking about trigonometry. It's a big word and it has pretty big meaning as well. It's the study of triangles. And as you know by now, you see triangles everywhere. You see them as the foundation of buildings. You see them around just basically everywhere. So it's a good thing to study. So this video, I'm going to be hopefully teaching you guys some more about it. So there's a couple main parts that I first want to refresh. So the first thing I want to refresh is special right triangles. It's pretty badly drawn. So the first main type is the 45-45-90 triangle, and that connotates that these two sides are equal. So I can write as x, and then the hypotenuse as x root 2, x times root 2 specifically. So the other type is, let's do this in red, is the 30-60-90 triangle, which I'll label this as 30, 90, and then 60. Oh, okay. They died on me. 60. And wow, okay. I'll just redraw that. Okay. And this is 60, and that side's 30. So we can tell that the 30 side, this will make it x. The hypotenuse will be 2x, and then the 60 side will be x times root 3, right? Okay, so with those special right triangles, if you see an angle that has 30 or 60 or 45-45, you can solve the triangle without really using the main parts of trig. Like, you probably guys have heard it and seen it on your calculators: sine, cosine, and tangent. Or as your calculators probably see this as this: sin, cos, and tan. Well, it's not how you say it. It's sine, cosine, and tangent. And you guys have probably heard the phrase now, Soh Cah Toa. Cah Toa. So this really just shows the relationships between, if I draw a triangle, right? And I'll just write this as angle theta. Theta is a term you use to place an angle. So according to this angle, what side would be the side opposite to this angle? The side adjacent. Where's the hypotenuse? So that's what these relationships all mean. So the S stands for sine. So I n, and this means opposite. Opposite, and this is hypotenuse. And this, the C is cosine. There's a space here. And this, the A, means adjacent. Oh, I used the blue to change the word. Okay, yeah, sorry. And then the H, again, stands for hypotenuse. So both sine and cosine both have hypotenuse in their relationship. And then this is tangent. Okay. And this is opposite, again, O. And the A stands for adjacent. So tangent does not use the hypotenuse in its um, relationship. So if I'm trying to find the opposite side to this angle here, where would it be? Well, it would be on this side. I'll just call that X, because this is the side opposite to this angle. So what side would be adjacent to this angle, theta down here there? Well, it would be this side. I can actually, okay, okay. I'll call this O, and then I'll call this A for adjacent, O for opposite. So where would the hypotenuse be? Well, it would be right here, since the hypotenuse always correlates to the 90-degree angle. So this is H. And no matter what angle it is in this triangle, the hypotenuse is still going to be the same place, right here. So let's clear the board. Alright, Soh Cah Toa up here for reference, but so let's say I have a triangle, right? And I don't know, this this can be angle X, and these values are 3, 4, and 5, right? So if I asked you what was the sine of angle X, what would this relationship be? How would you answer me? So first, you have to remember that sine correlates to opposite over hypotenuse. So in this angle X right here, what side would be opposite? Well, it would be 3 over here, so it's 3. And where would the hypotenuse be? It would be where it correlates to the 90-degree angle, so that'd be 5, 3 over 5. So if I have an angle here, and that's y, so let's do sine of y. So we have to look at a different angle this time. We can't look at where the x is anymore. We have to look where the y is. So what side is the opposite from y? Well, that's 4. And then where's the hypotenuse? The hypotenuse doesn't change places no matter where you go in this triangle. So it would still be 5. So I hope that makes more sense. So let me erase this. And let's draw this triangle. And it will do the 3, 4, 5 again. And oh, right, Soh Cah Toa again for reference. And what if I wanted to find, I'll make this angle x, cosine of angle x? What would that relationship be? Well, cosine, if you have to remember, it's adjacent, over hypotenuse. Adjacent over hypotenuse. So, what would be the adjacent side to this angle x right here? Well, it would be 4. And where would the hypotenuse be? 5. So using the same logic, I want you guys to find this angle y, cosine of angle y. What would that be? Well, the adjacent side to angle y here is 3, and the hypotenuse is the same again, so it's 5. So let's clear this. Oh. And this time I'm going to use tangent, so I'll write Toa down here, so not to get confused with Soh Cah, Soh and Ka. So let's maybe do something a little different. Let's do 6, 7, and I'll call this h because it has to be 6 squared plus 7 squared, then take square root of that. So I just keep it h. So what if I wanted to find the tangent of angle x? How would I do that? Okay, that's okay. This is an x. Okay, so the relationship between tangent is Toa, and it means opposite and adjacent. No hypotenuse involved. So tangent of x would be the side opposite to this angle x here, which would be 7, and then the side adjacent to x, which is 6. So the tangent of x is 7 over 6. Okay, so let's go back to the um 3, 4, 5 triangle. Okay, okay, Toa. So 3, 4, 5. So I've been telling you guys, calling this angle x, angle y, angle theta, and all whatnot. But what if I wanted to find this angle? Like if I had, let's use sine. Sine of angle x equals 3 over 5. How would I find angle x? Well, if you go to your calculator, right, turn it on, and make sure your calculator in degree mode. If you look at the top right side of your calculator, I'll tell you what mode you guys are in. And you guys are not in that mode or in radian mode, click on the top of your calculator, there's a button called mode, top left, click on that, and then scroll down until you see degree mode, click on that, and go back. And once you're in degree mode, we can continue. Okay, so on your calculator, this is a button called second. Click on second, then click on sine. You should see something like this, sine to the negative first power, like that. And that just means the inverse sine, because you use inverse sine to find angles. And so this is technically your sine x here, and equals 3/5. So you put in your ratio that you found. And if you do that, you should get your angle. X equals some angle, if you type it in. So what if I wanted to do this for cosine? Like if I had here, let's do 3, 4, 5 again for simplicity. So how would I do the inverse cosine? Oh, oops, that's x. So cosine of angle x. How would I do that? Well, how to find the angle x, I mean. So the ratio of cosine of angle x is 4/5. Adjacent over hypotenuse. So you would again click on second on your calculator, click on cosine this time, and you get cosine to inverse cosine of, and then type in your ratio 4/5, and you should get an answer. X equals something angle. And that's how you find the angle of any ratio where it's tangent, sine, or cosine. You must first find the relationship, so is it sine, cosine, or tangent, and then find the ratio like 3/5, 4/5, and so forth. And one more thing we have to learn. So what if I draw a triangle, and let's say this angle is 27 degrees, right? And this is 90, and this is the other angle. What if I had 3 here? No, not 3. Let's use 7. And I wanted to find the hypotenuse. How would I find the hypotenuse? The first thing you have to do is figure out what relationship you guys are using. You guys want to like trying to find Soh Cah Toa, right? So how I would do this first at the first time is to use process of elimination and just eliminate what can and what it cannot be one at a time. It takes time to get used to this. So if you the first thing I see in this triangle is that h, you need to find h. So you cannot use tangent in this context because it's opposite adjacent and has nothing to do with the hypotenuse. So it's either sine or cosine. And I look at the 7. Is 7 adjacent to the 27-degree angle, or is it opposite? Well, 7, the side, is opposite to the angle 27 degrees, so you would know to use sine. And then whatever your x is, but now you have your x, so sine of 27 degrees equals 7/h, right? 7 is opposite, and h is hypotenuse. And now solve for h using algebra. So multiply by h, so you get sine of 27 degrees times h equals 7. So you divide by sine 27, so you get finally you get h equals 7 over sine of 27. I mean, not h or hypotenuse. Type in the calculator and you get your answer. And make sure it's in degree mode. I cannot stress enough. There are people that fail the test because they forgot to put the calculator in degree mode. Remember, important stuff here, y'all. Okay, so there's 2 more examples and we're done. So I'll use black this time. So let's pretty bad neutron hypotenuse, but I'll make you guys find no. I'll make you guys find it again. So this will be 39 degrees, 90 degrees, and whatever. And this can be 12. And we have to find the hypotenuse. So the first thing you always want to do is figure out to use either to use sine, cosine, or tangent. So you have to find for the hypotenuse. So you cannot use tangent because tangent does not involve into hypotenuse. So now there's sine or cosine left. So is your side 12 adjacent or opposite your angle 39 degrees? Well, it's adjacent. So you won't not use sine. I'll put sine here. That was supposed to be but okay. Okay. Uh, so you would use cosine, and then your angle 39 degrees equals adjacent over hypotenuse, so 12 over h. And now you want to solve for h, so you multiply by h, and you do the you move it, then divide by cosine 39. Or a simpler thing to do is if you see this relationship, you just want to flip this over. Like take this and move places. So like this. So h equals 12 over cosine 39. I did just prove outrightly earlier that this works. So just swap the h and the cosine 39 term together and solve for h. It's a little trick, but it works. So one more example. And I will not use the Soh Cah Toa this time, so you guys can figure out the relationship. So if I have an angle here, and I'll use this angle, and this can be 47 degrees, and this I am trying to find this side. Oh, I shouldn't call that h actually. I'll call that x, and this is 10. So what relationship should I use, and how should I set it up? Let's guys get the time to figure it out. Okay, so in this situation, you want to use tangent because the hypotenuse is not involved, so it's not sine or cosine, so easy elimination, so it's tangent. And then tangent, whatever angle you have, 47 degrees equals, what side's the opposite side of 47 degrees? Well, that's x. And then what's your side adjacent to it? 10. To solve for x, multiply by 10, so 10 times tangent of 47 equals 10. Well, not equals 10, equals x. But, and before I leave, there's one more thing I want to talk to you about. So if you type out tan or cosine or whatever, you get something like this, right? And you put 47 and you're done. Don't don't do that. Don't get the habit of doing that. Just always close the parentheses out. So, and you use this in case there's another thing that comes after, like plus 2 or multiply by 2. So the 47 stays inside parentheses and doesn't get affected by any outside numbers or factors. So in this video, you have reviewed the special triangles, understand the relationship of sine, cosine, and tangent, learn to use the inverse sine, cosine, or tangent to find an angle, and then use sine, cosine, tangent to find missing sides. Well, thanks for watching, and bye.